We're looking at question 86 in the midterm review packet, and we're given a scenario here. And here's really the scenario outlined is you go up to a booth, there's a game of rolling a fair die, you pay X dollars to play. We don't know how much, X dollars. And you're told that if that die rolls a number less than a 3, which means 1 or a 2, then we get paid nothing. What that means is you paid X dollars to play, you roll a 1 or a 2, you walk away, you lost your X dollars. Now, if you roll a 3 or 4, they're going to give you your money back. So you paid X dollars to play, you rolled a 3 or 4, they give you back your X dollars, you broke even. Then you roll a 5, they'll pay you $1. So keep this in mind. You paid X to play, you give them X dollars, you roll a 5, they just give you $1 back. So you paid X, you get 1. Same idea for if you roll a 6. You paid X dollars, if you roll a 6, they'll give you 3. So there's actually two things going on really all the situations. So keep that in mind. And we're asked to find what value of X represents a fair game in terms of the expected value for both the person who is in charge of the game and the person playing the game. So the fair game means equal chance for both people to win or lose. So and really what I'm trying to find here is I'm trying to find an expected value equal to 0. No one should have any benefit over the other person, so fair means you have an expected value equal to 0. So expected value means I'm looking at the mean. Really I'm dealing with a random variable here, so I'm going to define it. That X equal the number rolled on a die. So I'm trying to find where mu of X, the expected value of X, equals 0. That's what I'm going for. So I'm rolling a fair die, 6 sides, same chance each time to go through. So I'm going to organize this as a probability distribution using a table. And so if I do that, here's my table. Now each one has a 1/6 chance of winning. Now keep in mind, if you rolled a 1 or 2, a number less than a 3, it says you paid X dollars to play, and they just keep your money, which means if I roll a 1 or a 2, I lose X dollars. Now if I rolled a 3 or 4, it said, hey, you paid X dollars to play, you roll a 3 or 4, they'll give you your money back. So I broke even, which means 0. I came out with what I started with. Now if I rolled a 5, I paid X dollars to play. Rolled a 5, they'll give me $1, which means 1 minus X. Because I paid X dollars of negative X, they gave me 1, a positive 1. So really the amount of money I got was 1 minus X. That was my profit. 6 is going to be along the same lines. If you roll a 6, you're going to have 3 minus X. Because you paid X dollars to play, negative X, and you got $3 back. I'll tell you right now, 5 and 6, those two right there are the ones that are going to cause the most problems because people forget you did pay X dollars. So though you got 3 back when you rolled a 6, you paid X to play. So you didn't make $3, you made 3 minus X dollars. So I have this right here, and so now I'm going to go ahead and calculate the expected value. And if I calculate the expected value, I'm going to take each money amount, negative X, times its associated probability, and so on, all the way down through the table. Now remember, we did learn that that has to be equal to 0. That's what we're going through. Our expected value has to be equal to 0 if it's going to be fair. So I'm going to combine these together. Anything multiplied by 0 is going to cancel out. So really right here, I have negative 2/6x. If I look at the 1 minus x times 1/6, I have a positive 1/6 minus a 1/6x. If I have the 3 minus x times 1/6, I have a 3/6 minus 1/6x. Now you can see the x terms are highlighted in orange because those are like terms, so I can combine those together. So really what I'm going to end up with, you can see here, is I have negative 4/6x plus 4/6 equals 0. So therefore x equals 1. So x equals 1 is my answer. It's what gives me a fair value. That's what we're dealing with in this problem. So let's kind of go back. We had the table. We found the expected value. We combined like terms. We wanted to find what x was. So then I solved for x, and I got x equals 1. Therefore, C is the answer. Now be very careful here. There's one that I really want to address, and that is choice A. If I look at choice A, what that did is it removed the idea of paying X dollars from the 5 and 6 roll. So if I were to just remove the minus x and the minus x and forget that I paid x dollars, so though they gave me 1, I did end up paying x, that would have given you choice A for an answer. So that's when I said the roll 5 and the roll 6 are the ones that cause the most problems, is because people forget, though you're getting paid $3, you actually paid x to play. So you have 3 minus x for what you're dealing with. You have 1 minus x if you roll a 5. So that's question 86.